Currently watching video E4.p2-32, the last of all of the videos for this particular unit, and this is going to be about rainforests and deserts. The learning target, E4.p2-I, is talking about different global wind belts, trade winds, prevailing westerlies, and polar easterlies. The primary focus of this one is going to be global distribution of rainforests and deserts, and talking about what causes those things to be located in particular places throughout the entire world, and more importantly talking about the vertical components of the actual winds that cause these things to actually take place to make rainforests as well as deserts. Okay, so a couple things I want to highlight first before we jump in. First of all, you will notice on your notes that there are a series of world globes per se on each of the pages. You'll see one here, you'll see one here on the following page as well. The reason why these globes are on your diagram is in the notes, as you're going to see right here in this diagram, you're going to see this global distribution of the types of climates that are found throughout the entire world. And while I'm going through the notes, I'm going to be asking you, as it says right there in your notes, to, as an example, shade in areas where mid-latitude deserts are found, or shade in areas where you find low-latitude deserts. It's more or less just a location type question that also will be used to kind of demonstrate exactly how the winds are actually traveling globally to make these deserts and or rainforests possible. So that's why the globes are there, just to kind of shade in areas to show the distribution of rainforests and deserts. All right, so with that having been said, let's jump in. As we've already gone over and discussed what the learning objective is, the primary focus, as I mentioned at the very beginning, is going to stay with the distribution of rainforests and deserts and why they're in the particular location that they are currently in. All right, so let's start by talking about rainforests and what rainforests are. First of all, at the equator, you have a series of large masses of air surrounding the entire globe. Some of those air masses can be hundreds of miles in width and length, but some of them can also be more than a couple hundred miles in width and length as well. So you could have an air mass that literally has just basically the same content from beginning to the end. In most cases around the equator, you're dealing with warm air masses. And as we've talked about with convection and conduction and radiation and talking about how different forms of energy move throughout the world and within Earth, we're talking about when warm air rises because of its density change. So what's going to take place on Earth as the density decreases, aka becoming lighter, which warm air is, it starts to rise. So the heated air is called the equatorial low because it has low pressure, because the density of the air mass is quite low as well. When the air mass rises to a great height, it begins to cool. The reason why it cools, the farther you get away from Earth, there are far fewer particles that are moving throughout the air, and as they run into each other, these particles, it creates friction, and as that friction is created, that helps to create heat. So as it cools, it begins to expand, which leads to the formation of clouds. You would know this from an example would be the tin can lab or even the cloud lab that you did at the very beginning of this entire weather unit, where as the cool air began to get dense, it's just simply you could see where the clouds would actually form within the glass because of condensation. And then that condensation eventually would turn into precipitation. So that's why this actual particular location, why rainforests form there, is because these areas have a constant flow of warm air that's always rising, cooling, and then precipitation falling back to Earth because of the condensing of that actual air. So when we look at the global distribution where we tend to find most rainforests, they're mostly found around the equator. And as you can see right here in this picture, the equator is this blue line that runs all the way across. And because rainforests are typically wet. The shaded areas that you see with this particular color, kind of an orangish red, are the areas where you're going to tend to find rainforests all the way out through in each of these areas. Now, it even comes up here. Both myself and my wife took 26 students a number of years ago to Costa Rica, and Costa Rica has what's called the cloud forest. More or less, it's a rainforest, and there's lots of moisture, absolutely huge trees, and lots of vegetation as well as animal species, and very unique because when we were in the cloud forest, we were, Costa Rica is not a very big country, but when we were in the cloud forest, the average temperature was in the 50s and 60s. You can always see clouds forming as that warm air rises off the ocean and comes up into the mountains, and then you start to see the clouds form and, condensation and then precipitation falling. But after spending a couple days in the mountains, we then started to make our way down to the beach. And we went from 50s to 60s pretty much every single day that we started up in the mountains. And then the minute we got out of the bus after traveling from the mountains down to the ocean side, our bus driver forewarned us. He said, "Look, you guys have been in this location and it's been pretty nice, but I just want to warn you, when you're walking on the beach, make sure that you have your shoes on because you'll burn your feet." Well, we were dealing with high school boys and high school girls, and some of the boys, being all macho, decided that they were going to get off the bus without their shoes. Well, what they didn't realize is that the temperature outside, because we were in an air-conditioned bus and didn't have the ability to pull the windows down, is that the minute that the door opened, we were hit with this massive burst of really warm air. And that air temperature when we first arrived down at the beach was 115 degrees. So we went from 50s and 60s all the way up to 115 degrees by just simply coming down the mountain, being right at the beach next to the ocean. And in this case, the student, boy walks up, "Oh, I can take it," walks off the bus. And the minute that his feet hit the sand, he started screaming high pitch, because instantly, the minute his feet hit the sand, these blisters, these really massive blisters started to form on his feet because of the intense heat from the sand and touching his skin. So he jumps on the bus, kind of dancing on his toes, in a lot of pain, because of the blisters that instantly formed. While the boys that were behind him that thought it was a great idea at first quickly were rushing back to their seats to get their shoes and learn their lesson through somebody else having learned the difficult way. But nonetheless, to be in an area that is a rainforest, I can tell you is really unique, but nonetheless, the climate is always changing based upon the elevation. So when you talk about deserts, the only desert that I have personally spent any time in is found in Arizona. My grandparents used to winter out in Arizona, so my parents and I would, around Christmas time, hop on an airplane and make our way out to Arizona to see and spend some time with them. And we would have to travel through the desert after we landed in Las Vegas in Nevada, and then travel our way to Arizona because they live closer to the Arizona-Nevada border. So what would happen with the deserts is that air begins to sink when you finally get to about the 30-degree latitude when looking at a globe. The reason why it begins to sink is once you start to move yourself, or the air mass starts to move itself away from the actual equator, the temperature of the air is going to start to vary. As the temperature of the air starts to vary, and more particularly it starts to cool, that air is going to begin to sink because its density is increasing. Where you have warm air, which is less dense, causing it to rise, you get cold air, which is starting to sink and condense because of its density. What happens is, as it gets closer to the Earth's surface, it's starting to be compressed and now starting to get warmed up again. It's the convection cycle, where you have warm material rising and then cold material sinking, and then again starting that process all over due to, again, receiving warmth and then rising again because it's less dense. So as a result, in this particular area, because of this constant movement of air, what tends to happen is you get a dry, sunny, in an area that literally has very little rain, and a lot of times that's why there's areas of drought, and that's why deserts will form in those particular areas. So as we look as to where deserts form, you're going to notice right from the beginning that we're looking for dry climates. And with dry climates, you're going to see kind of an orange color along with kind of a very light pale yellow, and they are located in different places throughout the entire world. And the one, as I was mentioning earlier, is located right there where my grandparents would winter. But you'll notice that there are other places throughout the entire world that also have those types of climates as well. And I'm sure there's some of you that have had the opportunity to go travel through a desert, maybe have flown over a location that has a desert, and literally you see very little vegetation. Cactus would be one example of the type of vegetation you would see there, but again, very, very little rain. And a lot of times, especially where my grandparents were, if they did get rain, a lot of times it would create what they call flash floods, because the ground is so hard that it's not able to absorb the moisture that falls in the form of precipitation, and then that would create an actual flood in that. Because of the elevation change and where they live, you literally could have this rain flowing very quickly down the mountainsides, headed into these small towns and villages that are found in Arizona around the mountains. So a very unique situation, and by mountains in Arizona, more like large hills per se. Low latitude deserts. Low latitude deserts are going to be found approximately 30 degrees north and south of the equator. So we're talking about, more specifically, the tropics of Cancer and also the tropics of Capricorn as our examples of 30 degrees north and south of the equator. Now, just above the tropics of Cancer and Capricorn, what happens for these actual deserts to form, it's simply because of the global distribution of air pressure and winds. And as you saw with global winds, talking about how they travel, moving from high pressure to low pressure, found in your global winds packet, that actual change in pressure will actually create the winds that we see taking place throughout the world. And from your activity, the global winds patterns, you'll know that we've got the prevailing westerlies, the polar easterlies, and the trade winds. And then if you want to get more specific about things, the winds closer to the equator, you're starting to deal with the doldrums. So those specific things are what cause these deserts to happen, because it's the transfer of air as it's moving from one location to the next in the form of a global wind. These low latitude deserts, again, just to the north and just to the south of the Tropic of Cancer and also the Tropic of Capricorn, as you can see right here, you'll notice that those are the areas in which you have these low latitude deserts. And these deserts, again, you're dealing with, in order to have a desert, you're dealing with dry climates. So more specifically, you're looking at these type of deserts in these particular areas being low latitude deserts. And the same thing down here. These being examples of low latitude deserts.